machine, like I say, I have Windows Virtual Machine, and by the way, this is running on ARM. This is Windows 11 running on ARM, which works just fine, which is very nice, even though, of course, this malware was compiled for Intel, but it works fine. So you have to download some malware samples, and you have to have a machine where you turned off the antivirus and the Windows, because it's full of malware signatures. So you download this thing, and let me just mention how to do this. The best way, your browser will also block the malware. So the best thing to do is download the 7-zip file, which it will not detect because it's an encrypted file. Download it, install 7-zip on your Windows machine, and extract it with the password malware. This is the standard in this business. We'll be doing it a lot. That way you can download a file, the browser will not recognize it as malware, and then on your machine you'll be able to unzip it and have the malware samples as long as you've turned off Windows Defender.
Yeah. I seem to remember that I got the warning message, even from downloading the zip file.
Yeah, well, if that's right, if you get the encrypted 7-zip file, your browser should not make a warning. And if you exclude the whole C drive from Windows Defender, then you should be able to unzip it. But it can be a struggle.
From Defender.
Yeah.
Defender.
Yeah, otherwise, Defender will block it because it has, of course, malware signatures in it. So that's the first thing. You need those samples. And then we're going to look at it, and the first thing would be VirusTotal. VirusTotal, Google bought them years ago. These will analyze files. So I can have labo101.dil. I could just upload it here. So on my machine, I put those things in the download folder, and here's the samples, and here's chapter 1, and there's labo101.dil. So I can send that up to VirusTotal, and it will tell me, many people have detected it. It's turned red. 46 out of 72 vendors flagged this file as malicious. So, like I say, you'll just get the name of it. Alibaba calls it Trojan Shiha 7B. Everybody has their own name for it. And then, like I said, if you go to details, it will tell you a lot, like the hash, and it will then tell you the names of the file that was sent up, which you can see are pretty clear, portable executable, like what kind of compiler was used. It will tell you the sections of the file, the text section, our data, how big they are, and hashes of the sections. It will tell you the libraries that are imported. And it will even run it often in a sandbox. This will tell you other files it's related to. And here's the IP addresses it connects to, which there's one here. And so it'll tell you something about other files that were connected to it, parents that led to this, and then some kind of resource parents, other files that might be bundled with it, a graphical summary of other files, perhaps. It just runs it in some automated process, and behavior will be, I think, the sandbox results, if it did that. Yep, here's group sandbox reports. Here's a variety of sandboxes, and here's a summary. This detected 1 MITRE tactic. ZenBox detected 6 MITRE tactics. Here's what they think of it. So, you know, they do a whole lot of things for you. Here's the various techniques that they think it did. And so on. So it gives you a lot of files written, files used, files opened, and so on. So, you know, it gives you a lot of information, a whole list of all kinds of behavior patterns.
Are we able to access the header with the VirusTotal?
The header, you say?
The header.
Well, not directly, but that's where most of this information came from, like the size of the segments and stuff. Yeah. But this they got by running it in a sandbox and feeding the dynamic behavior of it. So as I say, these automatic procedures are pretty nice, and you can't beat the price. VirusTotal lets you have all that information for free. All right. But as I mentioned, if you have real malware that you don't know and you upload it, you might have told the bad guy that they've been caught, because they will make a permanent record of this file and add it to their list. So you can, if you write malware and send it to people, you can go back here and check to see if VirusTotal knows about it yet. And then you will have exposed the fact that you caught them, which is not good operational security. So the safer technique would be to just calculate the hash and search for the hash. Then if somebody else already uploaded it, you'll learn about it, but it won't add anything to the database because the hash is not enough information to make that record. All right, so we can then use PEView to analyze this file. Let's run that. Now what I did, by the way, to install this stuff, I downloaded this file and unzipped it, and that gave me an executable. And the best way to install things, I should mention, I'd download it in the downloads folder, and then I'd unzip it and get the executable. And then I made a folder to hold all the tools called C Tools. Here's where I put them all. You put them all in one folder, and then to make it available, you right-click and you pin to the Start menu. Then you can just start it from the Start menu. This is an easy way to install these little executables that don't really have a full installer, so they don't really go in the Program Files folder and create registry keys and all that. This is, if you have little executables like this is a way to add them to the Start menu. It's a handy way to install things. So someone extracted the Windows 7Z, and I only see Labo 1. Yes, Bob, if you're only seeing those, that probably means that you have some kind of antivirus running on your machine that killed all the others. You'll have to get rid of your antivirus in order to see them all. You should see a whole, like 22 folders, and each of them should have like 4 or 5 malware samples. But if your antivirus is turned on, it'll destroy most of them. You have to, so take a look at project before this from last week, PMA 41. This one tells you how to turn off the antivirus. If you're using the Windows VM from me, it shouldn't be doing that. I don't understand. You'll have to share your screen later on Zoom and show me what you're doing then. If it's a machine that came from me, that should not be happening. Anyway, so let's try PE View. I can just go to the Start menu and PE View because I put it in that folder and linked it to the Start menu. So here's PE View, and I can open anything, and the labo101.exe is here. So this shows you the raw hex view of the file, and here it breaks it up into categories. You can see it has 3 sections: text, R data, and data, and it's got NT headers, and here's a signature, which is just PE, and a file header, and here you see a time date stamp telling you when it was compiled. So this sort of thing, you get there's various information. What's that?
Allegedly.
That's correct. It's not verified. That's right. This is what the stamp, that's right. You couldn't, in principle, put anything there. That's right. But if they just used a normal tool like Visual Studio and didn't modify it, it'll be accurate. And that's what most people do. But absolutely, remember, everything is imperfect. All these tools can be tricked. So you can't believe anything you see too much. A smart piece of malware will fool your tools. So it's just like a cop. You know, you find evidence, and that might prove that this guy did it, or it might prove that somebody planted that evidence there to deceive you. And that could happen here too. Yep. All right. So there's PE View. You just find something about the time date stamp, and that'll do for a flag here. Now we can try PEID on this file. If I run PEID, this will just tell you basically what language the file is written in. So if I open that same file here, labo101.exe, then it tells me it's written in Microsoft Visual C++, version 6, and you can see other things like how many sections it has and how big they are and such. But anyway, it tells you this. It gives you an idea of what language it's written in, and it can do a few other things about it. But the main thing we care about is this here. What language was it written in? Because it can detect a lot of packers, and it'll tell you if it was packed or compiled with a normal commercial compiler. This is compiled with what looks like Visual Studio, the most common thing people use for Windows software. And so now the most powerful tool, the one you should usually use first to make your life easy, before even thinking, use bin text. Strings is so easy. Don't waste your time struggling. The first, if you want to know what's going on with a file, bin text is probably your first one or your second one. This will just go to the file. I'll open that same file, Labo101. All right, and then go. All this does is read through the file and find all the readable strings. Everything always has this DOS mode. Here's the text and R data and data. These are the sections. These are Windows API calls: close handle, map, read, view, create file mapping. This is what Microsoft API calls look like. They're words just rammed together with capitalizing each word. That's the standard way they do it. There is a
function, right?
What's that?
There is a function.
They're functions inside a library.
Is a Pascal case.
Yeah, and here's the library name, and these are the kind of functions with this naming that they expect normal developers to use. Then you'll get to things like malloc, which is the kind of, in lowercase, those are lower level functions that most developers don't call directly. They call these bigger functions that call those. And these ones with underscores are function names that are not intended to be used by developers at all. They're intended to be used by internal functions. The function you call, like download file from URL, will call these other functions. And these are not intended, that's why they have the underscores. They're not intended for a normal developer to use, although you can. Here's something suspicious: kernel32 and kerny132.dil. The real Windows component is kernel32.dil. This is what malware often does. It makes a file that is malicious, that looks like a normal name, trying to fool you. So this is a pretty good, likely indicator of compromise. The presence of that file on a box is suspicious. However, we have to mention, we do not know what any of this means. These could just be strings put in there to fool you. We haven't proven that it actually creates that file. We're just seeing something that looks like a file name. But as a first pass, you learn a lot about the file this way with very easy. Here's the whole path, C Windows System 32, Kernel 132. So it looks like the malware is going to put that file on the box, and that's great. That's something we can easily test for to detect infected boxes. Then it's got running this will destroy your machine, and whatever that means. That's a scary message to pop up. Then some more API calls, and that looks like about it. But we were able to get quite a lot of information out of it. You notice I didn't see any domain names or IP addresses. It looks like this malware does not use the internet. Now, I haven't proven that, of course, because it could be concealing those strings, but I learned quite a lot, and it was very easy. I didn't have to use any complicated tools. That's why this should be one of your first things. Do this because it's so easy. You learn a lot, and all you have to do is read the text. Yeah.
So you're saying, if I'm understanding correctly here, you're saying that the casing, the type of casing that is being used in labeling these functions, the library,
Yeah.
etc., is already an indication of where the potential threat is, or is an indication of the actual threat?
It's just an indication of what this program does.
What the program
You'll
does.
see the calls it makes, and from then you can tell what it's doing. Like this one didn't have any network calls, so it doesn't seem to be using the internet. It didn't have download file from URL or anything like that. But it did have stuff about file handles, like find next file, find close, create file. It looks like it hunts for a file and then creates a file. So a common thing it might do is it would try to find that Kernel 132 file, and if it's already there, it would not recreate it. So it would be reinfecting a box that's already infected. So that's why it would use these kind of functions. Hunt through the file system to see if a file is there, and then maybe create the file, maybe not. I'm just guessing, but you can guess from this approximately what it does. But you don't really know.
Yes, I think that the question I was asking is slightly different, because I was asking, okay, which direction the type of casing using suggests me. So basically, if I read a label that is using Pascal case, so all the first letter capitalized.
Yeah.
What am I thinking of that? A function or a library? Or
Yeah, these are Windows API calls, and after all, I get used to them. That's the way they look.
Then the other one that you showed us, what is
malloc down here.
Snake casing, the one that has the underscore.
Yeah, those are also part of the Windows library, but they're not the part that developers usually use directly. But when you call one like copy file A, it will probably call some of these. But you don't directly reference it. That's why the name is not friendly to humans.
It's not friendly, but it still gives you an indication of where to look.
Yeah, and you could use it. The malware uses it, but probably not directly. Not that it matters, but yeah, as you do a little more Windows development, you get used to what Windows files are like, and that helps. So there's a couple flags to find by hunting through the strings here. And there's a spot where you're trying to find a 4-letter thing. By default, this strings tool only takes things that are 5 letters or longer. So to find one of the things you're looking for, you have to go adjust that. And you can adjust it to look for shorter strings. And if you do, you'll get more noise, but you can see shorter things. And there's another sample where you do find an IP address. So that's a place you can go. Now there's another tool called Dependency Walker, which I really don't use very much anymore on malware. It's a tool developers use. If you have a program and it turns out to try to load a library and it can't find a library, you'll get a missing DIL error. And this is intended to resolve that. So I'll show you what it looks like. But like I say, it's kind of confusing and I don't use it much. But this is it, Dependency Walker. And so you can open that malware sample like labo101.exe. And what it does is it shows you all the libraries it needs and all the functions it uses. And you can ignore the error message. All right, so here up the top left, you see it loads kernel32.dil. and I can shrink that down. And then it loads msvcrt.dil. So those are the two main libraries it uses. And then inside there, it loads more things like ntdil and kernel base. And if I pick one of these, it'll show me the exact functions it uses: close handle, copy file, find file. So these are the imports. These are the exact libraries that it uses there. Now remember, we looked in the strings and we saw like copy file and create file, and we guessed that those were API calls, but you don't know. Now you know. They really are API calls. This analyzes the structure and says it really loads that library and it really uses that function. But you don't get the whole function call. If I want to know it created a file, what was the name of that file, I'm not going to find it here. I'd really need to disassemble the real code to do that. This just shows me what library functions it uses. It doesn't show me the exact call with the argument. But I do know that it's really using this function, whereas strings doesn't really prove that. It could have just had the name of the function in there. Yeah.
Now, for the middle pane.
Yeah.
In the middle pane, you see that the second column has ordinal. So
Yeah,
the
these are
called.
these are the exports. And so if it's a, you normally won't have very many exports in an executable, but this is a library. And so libraries have tons of exports.
Okay, so my question is,
Yeah.
does the software, does the dependency?
Yeah, and if I go back to the exe, you see, I think it would have one export. It doesn't have much. Yeah,
Right.
yeah. So you can see, that's what this is for. You can see exactly what it uses in each library. But as we're going to see later, there's a better program that makes this easier. That's why I don't really use this one much.
Okay.
Yeah.
No, because my question is, okay, the
Yeah.
middle pane, what does the middle name does? Because the
This here?
the malware creator is calling the libraries in an ordinal way to confuse us.
Well, they might. They might write simple malware. This is pretty simple malware that doesn't try to confuse you.
Right.
But they might do nastier things,
Right.
yeah.
But then, because in the 1, 2, 3, 4, 5. Okay, in the second column you have ordinal. In the
Yeah.
fourth column you have a function.
If it has a
That
name,
is
yeah.
the real name. This is my question.
Yeah.
Is that the real name that the software is able to uncover?
I think it is, but I'm not quite sure. I think, yeah. And sometimes there is no name. We'll see an example if we go to the instructions.
Because the book was not clear.
Yeah, well, what happens is if you analyze the DIL, then you'll see the libraries. Let's try the DIL. So I go back to this product here. Again, it's my Windows machine, and I want to get back into Dependency Walker. Let me close some of these. I'm losing control. All right, there, okay. Let's try this was the exe. Let's try the library, which is here, the DIL. Okay. All right. Okay. It's still the exe. There it is. Okay, it's going to complain about something. Okay, now I have the library. And so, if I look at this doesn't do very much at all. It only calls a few of these functions, and here's what it exports. So it exports quite a few functions, but it only uses a few of these to create mutexes, which we're going to talk about. Mutexes are labels in the process, in the memory of your machine that can be seen by more than one process. So there are ways for one process to send a signal to another process. And malware often creates a mutex to mark this box as infected. So when you run the infector again, it checks and says, no, don't reinfect it because it's already infected. So this malware seems to do that. And go down to ntdil, you'll see here various functions. And in the project, there was a way to see one that didn't have names here. But let's go back to msvcrt in the exe. You'll see that was, whoops, whoa. The problem with the me. Yeah, I guess this is a problem when I move the mouse. I hate this. There are multi-finger gestures that do bizarre things. And I'm too clumsy to use it. I have to turn off all the stupid advanced features. Anyway, you can see some of the functions. This does a string comparison, string I comparison. But if I go down to the DIL, okay, then if we look at kernel32.dil, which is here, there, kernel32.dil, then you see here it is, opening a mutex, creating a process, and if I go to kernelbase.dil, well, I'm a little confused. Oh, that's the exe. We've been past. Okay, that was the exe. Down here. Okay, there we are. Now I look at WS232. That's the networking library. That's what I want to do. Okay. So I don't care about kernel right now. I'll shrink that down. WS232, this is networking. And so up here you see imports, it's importing functions that only have ordinals. They don't have names. But it's connecting to some kind of low-level function, low-level library that doesn't even bother to have names for internal use. But here it exports things, and these, you might be familiar, these are the standard, this is what the internet is. It was invented at UC Berkeley. These are BSD, Berkeley Standard Sockets. These are the basic functions for all internet connections. Bind to a socket, connect to a server, accept data, and there's going to be like send data. These are the basic networking functions that everybody uses that created the internet. So anyway, this is the library that does that, WS232, WinSock. This is what called low-level sockets, direct network connections in Windows. All networking uses this process because it all uses the basic code written by Berkeley for Linux, even Windows. So this is the library that gives you basic low-level raw sockets, they call it. Anyway, so there's a couple flags to find here and a couple other samples where you can just use various tools to find things. You just get to practice with these tools. So I'm going to stop the recording of this.